Okay, so we're still in question two, but we made it past A, B, and C, right? And A, B, and C required us to solve limits using some of our algebra techniques like factoring and canceling, kind of canceling out common denominators, things like that, but also multiplying by the conjugate. Now, in our next set of pieces for part two, we're going to take limits that are going to be related to infinity, right? So either limit at infinity or limits that are infinite. So take a look at D. First and foremost, we always plug in our value, right? We try and do direct substitution, see what the result is. So when I plug in infinity here, what I notice is that in the numerator, infinity times itself 4 times would stay drastically large. It would stay at infinity, even with the subtraction of 10, right? So if you have $1,000,000 and you take away $10, you more or less have $1,000,000, right? And conceptually, no one would really notice $10 missing. Same thing in the denominator. This infinity is going to go times itself 3 times, get scaled by 4, and then you add infinity again. That's still just a really large value. We're calling that infinity, right? This is an indeterminate form, just like 0 over 0, right? Infinity over infinity is an indeterminate form. Therefore, we need to do some algebraic technique to rewrite this limit into some other form for us to solve, okay? So, to me, based on things we've done in the past, I'm hoping to divide the highest power variable out of every single term, right? So what that means is I noticed that in the numerator and denominator, the biggest variable is x to the power 4, right? The biggest term that I have is x to the power of 4. And so what I'm going to do is I'm going to divide every single piece, every single term in my limit expression by x to the 4. So that means x4 gets divided by x4. 10 also gets divided by x4. 4x cubed by x to the 4. And x by x to the 4. Now the reason for this we've kind of seen, but essentially I'm able to rewrite all of the smaller terms as a ratio that involves x, hopefully in the denominator. And when you push to infinity, anything that's heavier in the denominator goes to 0, right? So let's just see this written out so it'll make a little bit more sense for us. So as we go to infinity, x4 over x4 is 1. 10 over x4, remember we won't touch that just yet. X cubed over x4 would leave us an x in the denominator, right? 3 left, canceled, you have 1. And 1 over 4 x's, we would be left with 3 x's in the denominator. Okay? Now, like I said, when we go to infinity, what we notice is that 10 over something that's pushing towards infinity is going to go to 0, right? If the denominator gets larger and larger, the fraction itself gets smaller and smaller. So here I get a 1. This term goes to 0, right? And then subsequently in the denominator, 4 over infinity would go to 0 as well. And then 1 over infinity, well, that's 0, right? So as we approach infinity, those terms kind of turn to 0. We're getting 1 over 0, right? So 1 over 0, which is pushing towards infinity. Now the question becomes, when we do this, are we going towards positive infinity or are we going towards negative infinity, right? Because we know that infinity more or less is a DNE, right? That technically infinity means the limit doesn't exist, but I'd love to give information about what direction we're really going in. So what I'm going to notice here is that in my denominator, these two things are both positive, right? And we're combining them. So I have a positive term and I'm adding another positive term. As we go to infinity, these, of course, all have positive signs. So if you're adding two positive terms, they're both going to 0, but they're both, positive in magnitude, we can assume. And so this would really kind of look more so something like 1 over 0, but for sure in coming from some positive direction, right? The numbers are positive, just getting closer and closer to 0 from the positive end. Therefore, I can make the claim that this is going to then go to positive infinity, right? 1 over 0 we know pushes to infinity, and the positive signs on both of those imply that we push to positive infinity. Okay? We can look at this graphically if we wanted to, and we would see that if you plotted this graph as we go far to the right of the graph towards an x to infinity, you would notice that the graph also pushes upward toward positive infinity. Okay? So this is kind of our technique here for that.